about the uniform circular motion. Definition: when an object follows a circular path at a constant speed, okay, the motion is said to be a motion of the object is called uniform circular motion. Okay, so the word uniform refers to the speed which is uniform, means constant throughout the motion. So suppose करिए an object is moving with a uniform speed v in a circle of a radius r, and if this, since the velocity of the object is changing when the particle will move in a circle, so the change in velocity leads to acceleration. For example, see, change in velocity, change in velocity in circular motion circular motion leads to acceleration. Okay, it leads to acceleration. So now we are here aim to find the magnitude and direction of acceleration. Magnitude and direction of acceleration. Now to find the magnitude and direction of acceleration, what we will do, we will just consider this circular path we are talking about. So this is the diagram. This is the center of the circle marked as C. So let P be the point from where the particle starts moving at time t is equal to 0 second. So this is the position vector of the particle at point P. This is represented as r vector. And then after some time delta t, the particle will reach at point P prime. So as it's have the different locations, so this is the position vector of the particle at point P prime. So P with the velocity, P is the velocity, let B is the velocity at point P, and B prime with the velocity at point V prime. Okay, so from P to P prime, the position vector change from R to R prime, and it is represented by some vector delta R. Okay, so it makes just some angle, some theta, delta theta from R to R prime. So this angle is some delta theta. So now as the velocity is changing from B to B prime, so if we have to find the change in velocity, so just we will draw a line from here which bisects delta R like this. So you can find the change in velocity from here. So this is the velocity vector, okay, and this is V prime. This is V prime. Now using the triangle law of vector addition, V velocity changing from V to V prime. So this could be represented by this line. This is delta B vector using triangle law of vector addition, and this angle is also delta theta, right? So as see here, R is perpendicular here, R vector is perpendicular to velocity vector at point P. This angle is 90 degree, and this angle is also 90 degree, means R prime vector is also perpendicular to velocity vector. Okay, so what does this mean? This means delta R, change in position vector, is also perpendicular to delta B vector. So now the position vector is along this direction. What does this mean? This means that the velocity vector delta B will points towards the center, towards this direction. So now here, if we have to define the average acceleration, so average acceleration is equal to, average acceleration is defined by delta b over delta t. So now this average acceleration is, now we can say it is directed toward the center. Average acceleration is also, now this average acceleration is perpendicular to delta r, is perpendicular to delta r. This means that it is directed towards the center. अब आप ध्यान से देखिए, इसका जो डायरेक्शन है वो सेंटर की ओर होगा. अब आप नेक्स्ट स्टेप में हम ऐसा करते हैं कि इस p और p प्राइम का जो स्पैन है इसको थोड़ा छोटा कर देते हैं. So I would like to redraw this diagram once again. Okay, so this point is now C once again. The same diagram. This point is P, and tangent to point P is the direction of the velocity at that point. So make it short. I reduce this time interval P prime, and this is the direction of velocity, which is B prime, and this is the another position vector. Delta theta is the angle between r and r prime, these two position vectors. Now bisect this, आप इसको दो टुकड़े कर दीजिए, and just see here, this vector represent the change in position vector. This is delta r vector. Now see here in this case, so this is the velocity vector b vector, and this represent the change in velocity. This is b prime vector. This is the angle delta theta. And now once again, from the triangle law of vector addition, delta b is represented by third vector, which is once again directed toward the center. So delta b, change in velocity, is directed toward the center. So the direction of change in velocity is the direction of acceleration. So this is once again remain perpendicular to the position vector. So here, for this case, if we will reduce the time interval between p and p prime, acceleration once again remain directed toward the center. आपने दोबारा फिर से क्या देखा कि यदि p और p प्राइम का जो टाइम इंटरवल है वो छोटा हो जाता है, मीन्स आप थोड़ी देर के बाद ही इसको ऑब्जर्व कर लेते हैं, डेल्टा टी को आप रिड्यूस कर देते हैं, तो एक्सेलरेशन का डायरेक्शन फिर भी सेंटर की ओर ही रहता है. अब थर्ड केस हम करते हैं, थर्ड केस में हम क्या करते हैं कि हम इसको और नज़दीक ले आते हैं. This is once again the center C, and this is the position vector P. Okay, now P and P prime now are at the same point. P and P prime overlap at this point. What does this mean? This means that when delta t approaches to 0, माने जो delta t is at this much time, delta t. So here in this figure, I will mark this as figure number 1 and this as figure number 2. So in figure number 10, delta t is large. In figure number 2, delta t is reduced. So it is delta t1, and this is take time delta t2. So I can say delta t1 is greater than delta t2. So now here in this case, delta t approaches to 0. You have reduced it. So जब आपने इसको reduce कर दिया तो आपकी पहली ऑब्जर्वेशन, पहले आपने पार्टिकल को यहाँ देखा, आप जो डेल्टा टी टाइम है वो बहुत छोटा है, मीन्स पार्टिकल बिल्कुल उसके पास दोबारा फिर आपने देख लिया. ओके, इन दिस केस व्हाट विल हैपन, so the velocity vector is remain tangent to this. So when delta t approaches to 0, what will happen, जो delta r जो है at this point, delta r become perpendicular to r. डेल्टा आर, ये देखिए ये वाला पॉइंट है डेल्टा आर, जब ये बिल्कुल नज़दीक आ जाएगा तो ये डेल्टा आर ऐसे ऐसे करके होगा, एंड इट विल बिकम परपेंडिकुलर टू आर. और इस लिमिट में क्या होगा, डेल्टा बी अप्रोचेस टू जीरो, डेल्टा बी भी जब जैसे डेल्टा टी कम है तो डेल्टा बी भी घट जाएगा, बिकॉज बी एंड बी प्राइम विल लाई वेरी क्लोज टू वन अनदर. So in this case, this will become delta b become perpendicular to v. So I can say that acceleration delta b is perpendicular to v. So delta v is perpendicular to v. What does this mean? This means that यहाँ हम इसका रिजल्ट निकलते हैं, for delta t approaches to zero, acceleration still remain directed towards the center. So you have seen three in the three figures. आपने फिगर नंबर 1, फिगर नंबर 2 और फिगर नंबर 3 में देखा, in every case acceleration remains directed towards the center. So throughout the journey of the circular motion, acceleration remain directed towards the center. So our problem was to discuss the magnitude and direction of acceleration. So till now we are very much clear about the direction of accelerations, that acceleration will always remain directed toward the center. जो acceleration है वो हमेशा center की ओर ही रहेगा, इस तरीके से यहाँ इधर की ओर रहेगा, यहाँ इधर की ओर रहेगा. एट एवरी पॉइंट जब तक सर्कुलर मोशन में पार्टिकल रहेगा, उसका जो एक्सेलेरेशन की डायरेक्शन होगी, वेलोसिटी विल रिमेन टेंजेंट. यहाँ वेलोसिटी की डायरेक्शन ये है तो एक्सेलेरेशन की डायरेक्शन जो है वो सेंटर की ओर है. वेलोसिटी की डायरेक्शन टेंजेंट है तो एक्सेलेरेशन की डायरेक्शन सेंटर की ओर है. सो दिस इज कॉल्ड, सो एज द केस इट इज कॉल्ड सेंट्रीपीटल एक्सेलरेशन. So its name is centripetal acceleration. Why? Because it is derived from the Greek word centripetal, means center seeking. So I will explain it at the end of the lecture. So now the question is to find the magnitude of acceleration. So next part is magnitude of acceleration. We will now go for magnitude of magnitude of acceleration. So to find the magnitude of acceleration, I would like to write that magnitude of acceleration, this is equal to, it is written as limit of delta t approaches to 0. We are discussing from this figure, delta t approaches to 0. So this is velocity vector divided by delta t. So now here we have to find the change in velocity. So to find this change in velocity, we will do something. So see here, when delta t approaches to 0, so we'll just take just one diagram. See in the figure, in this figure is somewhat I will mark as G, and then this part is H, and this part is now I. So as R is perpendicular to V and R prime is perpendicular to B prime, so this angle in the triangle as R vector is perpendicular to velocity vector and R prime vector is perpendicular to V prime vector. So I can say that triangle GHI is similar to triangle CPP prime. Okay, so if these two triangles are similar, so this angle is also delta theta. These two triangles are similar. You have to write it just like this. So as you have studied in the 10th class, the ratio of corresponding sides will be same. So as the case, I will try to write delta B vector from here, from this triangle. इस triangle से आएगा delta B vector. So from this triangle, this side is represented by delta R. So this is delta R vector. From this triangle, if you will take velocity, magnitude of velocity, and then from this part you will take the radius of the circle. So this is equal to V upon R. So from here on, you can define magnitude of velocity is equal to V upon R time magnitude of position vector. Okay, so from equation, this is equation number 1. and this is equation number 2. So from equation 1 and 2, from equation 1 and equation number 2, we have, from equation 1 and 2 we have this acceleration is equal to limit of delta t approaches to 0. Substitute over here, we have v upon r time magnitude of this position vector divided by delta t. Further, it could be written as v upon r could be taken outside. Now limit of delta t approaches to 0, magnitude of position vector divided by delta t. So now you reach to this point. This part is it could be discussed with the help of this figure number 3. So when limit delta t approaches to 0, what will happen then? डेल्टा टी जब 0 को अप्रोच करेगा तो डेल्टा आर जो अभी तक इतना बड़ा है, डेल्टा टी जब कम होता है तो डेल्टा आर और छोटा हो गया. तीसरे केस में आकर यहाँ डेल्टा आर कितना है? इट इज़ वेरी वेरी स्मॉल. So it is very very small. So delta r in this case is approximately equal to from figure 3, ऐसे लिखते हैं हम, from figure 3 as delta t approaches to 0. What will happen then? इस पॉइंट पर क्या हो जाएगा? हम ये लिख सकते हैं कि जो डेल्टा आर है वो इतना छोटा हो जाएगा, क्योंकि यहाँ दो वैल्यूज वेलोसिटी के नहीं, देयर इज सिंगल वैल्यू ऑफ वेलोसिटी, इंस्टेंटेनियस वैल्यू ऑफ वेलोसिटी. ओके, देखिए p और p प्राइम जो है वो वहाँ लगभग नियरली दे ओवरलैप. सो वी कैन नॉट मार्क द टू वेलोसिटीज v एंड v प्राइम. So you can write the single value of velocity, that is v. So v delta t. So v this is instantaneous velocity, that is delta r upon delta t. So this is another equation. I mean this is equation number 3 and this is equation number 4. So the magnitude of acceleration is equal to v upon r, and you can write in this case this is velocity. So this will become v square upon r. So this is what the centripetal acceleration is. AC, centripetal, is equal to v square upon r. So this is called centripetal acceleration. Why? Because this is called centripetal acceleration. This is AC is called centripetal. This is called centripetal acceleration. So why this is centripetal? Centripetal dictionary meaning means it's derived from the Greek words center seeking. Greek meaning is center seeking, जो लगातार सेंटर की ओर ही रहे. So as the case it is called centripetal acceleration. अब आप यहाँ देखिए कि in that centripetal acceleration AC is equal to v square upon r. You know that the velocities, the speed of the particle is constant throughout the journey of uniform circular motion, and this is the radius of the track. So both v and r constant here. Both v and r are constant. Both are constant. But direction of acceleration changes. So we can say that acceleration is not a constant vector. So with change in direction, so acceleration is centripetal acceleration is not a constant vector. It is not a constant vector. So we will now proceed for the another definition, another part of this video to discuss about it a little more, so another way to define this centripetal acceleration. There is another way to define this acceleration. So we will just see in the diagram. We do have the diagram. हमारे पास ये diagram है वो कुछ इस तरीके की है. We do have the diagram of this kind. This point is P and this point is P prime. Okay, this position vector is R and this is R prime vector, and this is delta theta is the angle between R and R prime. So this is what the R vector, delta R vector is. So you know everything about it. So we will define two things. The particle is at point P when t1 is equal to some 0 second. When particle is at point P prime, जो आपका समय बदल कर कोई t2 जो है वो t seconds हो गया. So delta t is equal to t minus 0 seconds. So this is some delta t. So the particle from here to here, it follows some angular displacement. So angular displacement इसमें हुआ है. So the angular displacement से हम एक term define कर सकते हैं. This is called angular speed. Okay. So we do have the time rate of change of angular displacement leads to the new term. This is called angular speed. Okay. So angular speed is equal to delta theta upon this delta t. Okay. So this part is this is equation number 1. So by definition, if the distance traveled by the object during this time interval from p to p prime, यदि एक जो object है वो कोई distance delta s कवर करता है, तो आप angle की definition से आप लिख सकते हो कि delta theta is equal to sum delta s upon delta t, right? So velocity, you will define from here, velocity is equal to delta theta is it is delta s upon r हो जाएगा. So delta s is equal to, okay, I will erase it. So we can write that velocity is defined between the point P and P prime is equal to delta s upon delta t. So but आप इस डेल्टा एस को आप कैसे डिफाइन कर सकते हैं? डेल्टा एस इज इक्वल टू रेडियस टाइम डेल्टा थीटा. आप जानते हैं कि यदि आपके पास ये एंगल थीटा है, okay, and this angle, this length is some s, and this is r, then theta is s by r. So s is equal to r time theta. So I have used the same concept over here. Okay, so put it here. From this is equation number 2 and this is 3. So put here from equation 2, velocity is now r time delta theta upon delta t. So this delta theta upon delta t from equation number 1, this is omega. So we have velocity is equal to r time omega. Okay. So you can now express the centripetal acceleration in this form. Centripetal acceleration will now be v square upon r. So v is now r omega whole square divided by r. So this is equal to sum r square omega square over r. So this is equal to omega square r. This is another way to write the centripetal acceleration. So further we will define that जैसे एक particle है वो एक circular track में ऐसे घूमता है. So time taken by the particle to complete the one circular track is called the time period, and it is denoted by capital T. Okay, and the second is the number of revolution made in 1 second is called frequency. एक सेकंड में वो कितनी बार इसमें घूम जाता है उसको हम उसकी frequency बोल देते हैं. Okay, so however during this time interval the distance कितना move करेगा? It is equal to the circumference. एक बार जब वो एक सर्कल में घूमता है एक पार्टिकल, तो उसके लिए वो टी टाइम लेता है। जितनी बार एक सेकंड में वो घूम जाता है उसको फ्रीक्वेंसी बोलते हैं, और इसका जो टोटल डिस्टेंस है वो 2πr हो जाएगा। ओके, सो s इज इक्वल टू 2πr। सो नाउ विल डिफाइन दैट वेलोसिटी क्या होना चाहिए। ऐसे में वेलोसिटी क्या होना चाहिए। सो दिस इज वेलोसिटी विल नाउ बी, this is 2πr divided by t, and you can write it like that, 2πr into frequency। तो इसको आप फिर सेंट्रीपिटल एक्सेलरेशन में भर सकते हो। सो सेंट्रीपिटल एक्सेलरेशन में यदि आप भरोगे तो ये आ जाएगा 4π² r² ν² अपॉन r। सो दिस इज अनदर वे टू राइट 4π² r टाइम ν²। So this is all about the different forms of centripetal acceleration. So you are asked one problem, problem number 4.10. So you have to open NCERT book. I would like to go through this. See here, this is a problem number, this 4.10. This is a problem number 4.10 to understand the application part of this. आपके पास एक insect है that is trapped in the circular groove of radius 12 centimeter. So what is given to you? Write it here. A radius is equal to 12 centimeter. In SI unit it's 12 cross 10 to the power minus 2 meter. One thing. And then groove and completes a 7 revolution per second. So जिसका frequency है वो है 7 revolution in 100 seconds. So 1 revolution is 2π. So अभी तक इसको ऐसे रहने दीजिए आप, 7 revolution per second. Then you are asked to find the what is the angular speed. आपको एक angular speed निकालना है ओमेगा, and linear speed एक आपको v भी निकालना है। तीसरा आपसे पूछा है कि is acceleration is a constant vector but is its magnitude, और आपको acceleration भी निकालना है। सो पहला सवाल है कि यदि आपको ओमेगा निकालना है तो ओमेगा का जो फार्मूला होता है, ओमेगा का जो फार्मूला होता है वो है 2π/t, दैट इज 2π टाइम न्यू। सो न्यू आपको दिया हुआ है, इधर आप लिख सकते हैं 2π इंटू 7/100। सो इसको यदि आप सॉल्व करते हैं इट विल कम आउट टू बी 0.44 रेडियंस पर सेकेंड। एंड वेलोसिटी आपको निकालनी है तो वो ओमेगा टाइम आर है। ओमेगा आप यहाँ से इस्तेमाल कर लेंगे, और रेडियस आपको दिया हुआ है 12 सेंटीमीटर। सो दिस इज ओमेगा इज इक्वल टू 0.44 सेकेंड माइनस 1 क्रॉस 12 सेंटीमीटर। ओके, सो दिस इज 5.3 सेंटीमीटर पर सेकेंड। फिर आगे अगली बात आपसे पूछी हुई है, हमने एंगुलर स्पीड निकाल लिया, वेलोसिटी निकाली, एक्सेलरेशन निकालना है। सो एज द क्वेश्चन टू द एक्सेलरेशन इज ए कांस्टेंट वेक्टर। ये हम इसकी एक्सप्लेनेशन आपको पहले ही दे चुके हैं कि जब एक पार्टिकल सर्कुलर ट्रैक में घूमता है तो उसमें हमने 3 फिगर्स बनाए थे। 3 फिगर बनाने में हमने फिगर 1, फिगर 2 और फिगर 3 में हमने ये देखा था कि एक्सेलरेशन इज ऑलवेज डायरेक्टेड टुवर्ड द सेंटर। सो वो हमेशा सेंटर की ओर रहता है, और उसकी डायरेक्शन जो है वो देखिए हर पॉइंट के ऊपर उसकी जो डायरेक्शन बदलती जाती है। से जो सेंट्रीपिटल एक्सेलरेशन है वो होता है v² अपॉन r। इसमें स्पीड कांस्टेंट रहती है क्योंकि यूनिफॉर्म सर्कुलर मोशन है, r रेडियस ऑफ द सर्कुलर ट्रैक है, तो मैग्नीट्यूड तो कांस्टेंट है बट चेंज इन डायरेक्शन की वजह से जो वेक्टर है वो लगातार चेंज होता रहता है। सो हम ये कह सकते हैं कि इट इज नॉट ए कांस्टेंट वेक्टर, not a constant vector. So if it is not a constant vector, then what is its magnitude? So its magnitude A is equal to omega square r. So आप किसी फार्मूले से कर सकते हैं, आप v² अपॉन r से भी कर सकते हैं क्योंकि आपने वेलोसिटी भी निकाल रखा है। सो ये आ जाएगा 0.44 सेकेंड माइनस 1, इसका स्क्वायर कर देंगे, और जो रेडियस है वो है 12 सेंटीमीटर। So that is equal to 2.3 centimeter second minus 2. So this is all about this video, and it is the end of this chapter. I will now start discussing another chapter that will be the laws of motion from the next video onward. Thank you very much.